So I'm going to break this microwave down. I'm not going to talk about the whole microwave and how to troubleshoot the whole microwave. I want to talk about the 3 door switches today. And we'll break down microwaves in pieces and talk about specific components on this unit. The one thing about this microwave is that there are 3 door switches usually on a microwave. Some microwaves have more than 3 door switches, but they at least have 3 minimum, and that's usually the average for most microwaves. The only ones that are going to have a lot more door switches are usually more higher end units that put more stuff within the circuitry. But we got something called a primary interlock door switch, and you notice how they say upper. So they're saying that out of the 3 door switches, we have one here at the top, we have one in the middle, and one at the very bottom. I got a picture in the next slide to show you them again. The upper door switch is not always the primary door switch. So just because it says that's the location of that part right now, that doesn't mean it's always there. And I'm going to tell you how to look at it and how to know which one is which. So we got the primary interlock, and then we got another door switch. This one is called, it says door switch here, but it's also known as the door sensing switch. So it senses whether the door is open and closed, and I'll explain you that one as well. Then the final door switch is the monitor switch. You don't need to really worry about interlock, but it's the monitor switch. And all 3 of those switches need to be closed for the microwave to function properly. But do they? Do they all need to be closed? Look at the schematic. Look at the 3 switches. What do you see if you look at the schematic? We got one here, and one here. Do they all look the same on the diagram?
No.
What's different?
The primary is closed and the interlock is open.
Okay. And what about the door sensing?
It looks closed.
It's closed also. So these 2 are closed when that one is open, and vice versa. Okay? Now, let's talk about their purpose. We'll start off with the door sensing switch and what it does. And again, I try to teach you guys, you could troubleshoot all 3 of these door switches without ever putting a meter on the microwave. You could just turn the microwave on and know whether one of those switches are bad or if all those switches are good, just by turning it on. So how do we do that? Okay, first of all, the door sensing switch. This one here is connected directly to the computer board. If you look at this big rectangular box here is the computer board, and I'll just draw a line here. This is the control panel. Right here. This is the main board. The door sensing switch is connected directly to the main board. There's 2 wires coming from that switch, going right to the board, touching nothing else. And if we look at this bottom door switch here, we got these 2 blue wires. And one thing that we can notice is that these blue wires are smaller than all the other wires. And if you look at this one plug here, this one plug goes to the door switch. I'm sorry, and the other end goes to the board. All right, what's the purpose of that door switch? Anybody know? Anybody have any idea of what that door switch does? The door sensing switch?
It turns the light on and off.
Turns the light on and off. So when you open and close the door, the light goes on and off. So let's just plug it in. So when I open up the door, the light comes on. I don't know if you guys can see through there, but the light's on inside the cooking area. When I close the door, the light goes off. But that's not the only purpose of that switch. Anybody else have any ideas?
Stop it from running.
To stop it from running. Very good. But what is it doing with that? It's telling to stop from running, but it's telling who what?
The door's open.
No. It's telling who What?
The computer board.
It's telling the computer board that the door is open. Okay? So if I just take this thing and unplug it, the light's on. I don't know if you guys can see the light coming through the holes there, but just by unplugging that plug, the light comes on. The light goes off. Listen to the relay on the board. Ready? Hear that?
Yeah.
That's relay number 1 on the board here. The oven lamp relay. The oven lamp relay has more than one function. It turns on the light, but also controls the fan motor and the stirrer motor, which is the one that bounces all the microwaves around. I'm going to go a little bit farther in there on that in a minute, but I want to talk about the other door switches. And then I'm going to show you, I have a problem in this microwave. I didn't want to take the problem out. I'm going to leave it in there to show you, oh, this is how we know. Okay, the second door switch is the primary interlock switch. And I'm going to erase that circle right here, because if we look at the circuit for the light, power comes in, goes here right through the light, through that relay. That relay is going to make it back to neutral. I don't know where it connects to neutral here. It doesn't show me a connection to neutral, but it connects to this neutral and runs out like so. And so when that door switch opens, this relay closes, that light comes on. But when we're cooking, the light comes on inside the microwave as well, right?
Mm-hmm.
So when we're cooking, the light comes on, it comes on to that relay. But when that relay closes, not only does the light come on, but that relay also controls the fan motor and the stirrer motor. Okay? But they're not on when I open up the door. Why? When I open and close the door, the light comes on, but that same relay turns on the light, turns on the fan motor. That's this fan right here. I don't see that fan running. So why doesn't it run when I open the door? Anybody know? Because they have to go through the other door switch in order to work. If that door switch is not closed, the fan don't come on. So watch this. I disconnected the door switch while it's open. I opened the door. The light came on. We hear the relay, right? We're hearing that relay number 1 click. But the fan didn't come on. But wait, when I open the door, the fan's not supposed to come on, right? Yeah, but when I open up the door, I opened this one and I opened that one. Is the door open right now? The door's closed. So if this switch was bad, not only would the light come on, but the fan and everything will run even without pressing start. It's not running now, so what does that mean?
Good.
I mean, it's good.
No. It means that my primary door switch is bad. Now let's look at it another way. If I go ahead and tell my microwave to run, I'm going to press time cook 2 minutes. I press start. Watch what happens. It wants me to set the clock here. Hold on 1 second. I press start. Light came on, if you guys can see the light inside the cooking area. But you don't hear the microwave heating. You don't hear the humming of the transformer.
Because that door circuit is dead, and it's not completing the circuit. It's not starting the
Nothing past the door switch is running. You don't hear the transformer.
Right.
And the fan motor, the stir motor, or the turntable motor are not running. Okay, problem is what?
The other door switch.
Primary door switch. Without even putting a meter on it, if you know what each component controls, you can troubleshoot it out. Now, the monitor switch, you know, if the monitor switch is bad, there's two things that could happen when the monitor switch is bad. Either the switch never closes or the switch never opens. If the switch is closed and you open the door while it's running, you're going to blow the main fuse in the microwave. If the switch is open and never closes, it does not affect the microwave. I'm going to show you. I'm going to take that switch out of the microwave and we'll be able to run it and make it cook and do everything we want it to do. So let's take a look at this door switch for a second. They said that the door switch, the primary, is the upper door switch. So that's the door switch on the top here. So that's this one right here. Take the switch out. I hear it clicking, right? So what I want to do is I want to test the door switch.
Check for continuity.
I'm going to check and see if the switch closes. So I'll put my meter on there, on the two terminals. If I get my hands on it. Can't get my hands and hold the meter and everything else. If I had alligator clips set up, it would be nice, but. So if I check this door switch, well, if I touch these two together to prove my meter's working, and my meter's working, so my door switch is bad, right? So let's take this door switch. Let's take this door switch apart because we're going to see what I did. Put a little piece of tape in here. Let's see if I can find it. I don't see the tape in there. It might have fallen out when I opened it. So let me put this back together for a second, then I'll show you guys something. See if the meter's working. Hold that up for me for a second. Can you move the camera? You don't want to be on film? Now the switch is working. So let's put the switch back together. If you see here, you can see how the switch opens and closes. Can you get that on there? So if you guys see, can you see how the switch, when I touch down the button, how it actually makes contact on the switch? Is this a normally open or normally closed switch?
Normally closed.
What do you guys think?
It's a normally open switch.
It's normally open switch. Well, what makes you say it's normally open?
Yeah, that's
Because it only closes when the door's closed.
Yeah, that's a normally open switch.
It's open right now, right? Not till I press it down
It doesn't close.
that it closes. So the switch is a normally open switch. The monitor switch is the opposite, which would be normally closed. Okay, so now that I fixed the switch, supposedly, put it back together again. I'm going to stick it in its support here. Plug the wires in. And let's see what happens. Plug it in. Microwave works. Okay, so I said if the primary door switch was good, if I opened up the secondary door switch, or also known as the door sensing switch,
It was still no.
not only would the light come on, but the fans and stuff will come on. So watch this. So if I disconnect this from the board,
Fan comes on automatically.
it's not heating. Listen to the difference. That's the fan, the turntable, and the light. That's these three, or actually these four. I don't think it has the stirrer. But the transformer here and everything didn't come on when I did that. I'll do it one more time for you to listen, because this relay will only close if I tell the board to run. Okay? So this will not close because it sees this door switch open. It will not let it run. But when this door is open, it closes this one trying to turn the light on, but that light's turning on other things as well. So if this was bad, watch this. Light stays on, but the fan shut off. That's telling me the primary door switch is working. I know the primary door switch is working, and those are turning on and off. I'm not using a meter to test these. This is, if I know what each switch is controlling, I can tell what that is. So, if this switch is bad, what happens is customers will call you out and say, and they'll have the microwave unplugged. You know, you get there and it's unplugged. They're like, you know, why'd you unplug it? Oh, because it's running by itself. Because they think it's cooking. Now, listen to this noise again.
Transformer, come on.
Now I'm going to turn on the transformer and the cooking components through the regular control. You're going to hear those same noises you just heard, but you're going to hear additional hum. And then listen closely, because after it hums, you'll hear a slight buzzing sound, like zzz, almost like a fly on a window. That's the magnetron kicking on. So listen for the transformer, and then the magnetron to kick on after that. Ready? You hear how it even dropped low?
Yeah.
Couldn't really hear the buzzing sound that time.
I heard it.
It'll be a lot faster now. Okay? So, if the sensing switch is bad, it'll make it seem like the microwave is working when it's not supposed to be. If it's running, clock is counting down, it's the primary door switch. But what about the monitor switch? The monitor switch is very funny. The only purpose that that switch ever has in a microwave is if those other two switches fail to open when the door's open, like both of them are stuck. That's why they have so many door switches in there. If those two stuck closed and don't open, the monitor's there to blow the fuse and say, shut that thing off, because we don't want it cooking with the door open. So I'm going to go ahead and open the door. I'm going to unplug. I can get it out. I'm taking the monitor switch completely out. I'm going to put it over here on the stove. Right? Let me plug the microwave back in. What's going to happen? What's going to happen? I took the monitor switch completely out of the microwave. As a matter of fact, this one's broken. The button's stuck inside. Just notice it. Well, what's going to happen?
Nothing.
Nothing? Nothing, like nothing's going to run?
It's gonna run. It's a failsafe.
Okay, so what is nothing that's going to happen?
It won't stop the microwave from running even if the door is open.
No, it'll stop the microwave from running with the door open.
But it won't stop the microwave from running if the door switch fails.
If you open it while the microwave's doing, if it's in the microwave, it'll blow the fuse. I removed it. My question is, what will happen now if I remove this switch? Will the microwave do anything?
It keep running, wouldn't it?
Nothing will happen. It'll work just like normal.
Yeah,
Watch
nothing.
this. I'm gonna go ahead and listen for the hum, the buzz, everything, right? Okay, I open the door, microwave shut off. I press start again, microwave runs. If the monitor switch is bad, it's not going to stop the microwave from working.
It just won't blow the fuse if there's an issue.
It won't act as a safety device if the other switches fail to do their job.
It's a failsafe.
So let's explain though. if the primary switch is bad, this one, it'll run, light will come on, they'll start counting down, no fans or nothing. If the fans and stuff are working and we're not getting heat,
The primary's bad.
well, no, if the fans are working,
Oh, I'm sorry. The fans are working the second. The door sensing switch is bad.
no, because the fans won't come on if the door sensing switch is
The
bad.
monitor switch.
No, we got another problem. If it's running and not heating, but all these components are working, I might have a high voltage problem, or that relay on the board is bad. But that has nothing to do with the door switches. But one of the things that I wanted to bring up about the door switches is, why are we talking about this? You said you're just going to talk about door switches. Well, when you're in a customer's house, if this thing's hanging in a cabinet, the only access you have to all the components is here at the front of the door. Right? This is my only access. And if I wanted to check any kind of voltages or whatever, if it was running and I saw the fans and this working, my door switches are good. If the fans are working, my primary door switch is good. If it's counting down and the fans are working, my door sensing switch is good. I don't need to test them. If it's counting down and my fans and lights are working, those door switches are good.
Which means the problem has to be something else.
Problem has to be something else. Somebody there?
Yeah, just like that.
One second.
He left. He going out the door.
It's probably because you might be one of the welding students. Okay, so if all of them are working, it's not a door switch problem. So it might be,
A magnet.
I'm not getting 120 volts to my transformer because the relay's bad. Or I'm getting 120 transformer, problem is one of my high voltage section. We're not going to talk about that today. But the monitor switch gives you an opportunity to check to see if I'm getting power to my transformer. Watch this. I'm just going to erase this here just so it doesn't make confusion here. But if you called me on the phone and said, I need help, my microwave's running, not heating. What's running? The light's coming on. Okay. Is it counting down? Yeah, the clock's counting down. That means the door sensing switch is good. Because the computer won't count down if this door sensing switch is bad. Period.
It's a transformer problem.
Wait. Are the fans and turntable working? Yes, the fans and turntable working. Then what? My primary door switch is good. And the monitor has nothing to do with cooking, so the problem is not door switches. So the problem's relay or power to the transformer. So my first statement to you is, Imran, I need to check power to the transformer. Well, I can't get to the power of the transformer. It's back there behind the transformer. And it's in the customer's home. I can't get into this little opening and get back there and check power. I don't have room. Well, check from the monitor switch, because if you look, one side of the monitor switch is one side of the transformer. The other side of the monitor switch is what? The other side of the transformer.
So you should be able to check the power coming to the actual transformer through the monitor switch.
If I check the power going to these two wires on the monitor switch, it's the same as checking power to my transformer. So let's see how we do that. So I took this plug off, and we got a black and a white wire and a white wire. We got a black wire here with a white wire, and then we just have a white wire on this side. So if I take my voltmeter here and set it up, see if I can knock it down again, and I plug it into these two wires. It doesn't matter if my door switch is there or not. I put my voltmeter here and here. Oops. I'm gonna have to hold it. And I go ahead and press start. I got voltage. When I press stop, the voltage goes away. So what does that mean?
You mean the transformer's good?
No, it doesn't mean the transformer is
transformer's
good.
getting 120.
Means that you getting power.
It means I'm getting power, but it means what?
The monitor is good.
No, the monitor's not even in. I got the monitor sitting on the table. It means that relay number 2 on the board is closing, and the problem is not my board. This relay turns on all this. This relay turns power to the transformer. I have power. Relay number 2 is sending power. Problem's not my door switches. Problem's not my board. The problem is my high voltage components. All I need to do is ohm out the capacitor and diode. If they check good, 99% of the time, magnetron's bad.
So you've taken the microwave down off the wall at this point?
Well, you're going to have to check the high voltage side.
So you'd have to pull it down at that point.
You'd have to pull it down to get to those components because they're so far back. And a lot of them, the fan is located right here, separating the two sides, so you can't even get to that. Without taking it down out of the cabinet and taking this cover off, you cannot get to these high voltage components. And those, definitely make sure the machine's unplugged. You saw I have my hands in there, but I'm careful. I know what I can touch and I don't touch. This is high voltage and it's very dangerous. You guys shouldn't do this without gloves and not knowing what you're doing. I don't want anybody to just start going in there and playing with wires, because that capacitor stores 2,000 volts electricity even when the microwave's off.
Isn't that the one where you take the screwdriver and you touch it to...
We use something to discharge the capacitor before we touch it. Now, the capacitors have a bleed resistor internal. It means they have a resistor between the two terminals where all the wires go. And they got a resistor in there, so when the microwave's off, it's supposed to slowly let it discharge. But we don't trust that that is good when we come to work on it. We manually discharge the capacitor before we start pulling stuff off. And I told all you guys, and I give all you guys gloves with the rubber, palms, so that when you're touching stuff, you don't get electrocuted. You unplug the machine, and you go in there and check those components out. So, recap. Primary door switch is bad. Light will come on, clock will count down, but no fans, no high voltage section. That's it. Okay? It's not the board. It's the primary door switch. Now, if it don't count down,
It's the monitor switch.
it's the door sensing switch.
Well,
Remember, the monitor switch has nothing to do, it just blows the fuse.
The door sensing switch, yeah.
And if the monitor switch, we have problems with some of these microwaves, I'm not going to mention a brand, they change the way the switches are mounted on that brand. They move, and they're not supposed to. And if one moves, and you get this door switch and this door switch closed at the same time, before that relay opens, if we look at this circuit here, and I'm going to just bring it up. Okay, that if power goes through that door switch and goes through the monitor switch and through the relay, there's no load, like fan load or whatever, in that circuit I just drew. It's going to blow the fuse right here. And that manufacturer has a lot of fuses blown. Usually, when that happens, you ask the customer, was it running? You know how you guys are, you younger guys grew up and everything's fast, everything's done. Back in the day when I was a kid, we didn't even have microwaves. I remember microwaves came in I was like 5th grade or 4th grade. Okay? You guys put something in the microwave and you put 2 minutes, and a minute and a half you're opening the door because you can't wait 2 minutes. I know one person, he'll wait 2 minutes, but the rest of you open the door, and that's okay because the door switches are meant to save that. But on this design of these switches, if the wire is not plugged firmly onto the switch, the plastic around the wire actually holds the switch steady. If it's not firmly in there, the switch can move, and you can have this switch and this switch close at the same time. It's not supposed to. One's supposed to open and the other one closes before they both do it. So if it opened and this relay here and those two are closed at the same time, it's gone to the point now that it not only does it blow the fuse here, sometimes it avoids the fuse and cuts the circuit breaker in the customer's home. Like that fuse doesn't even trip, the voltage short is so high. Now, one of the things that happens, and you have to check this out, is that sometimes when that short goes through that relay, the contact in the relay stays closed. So if you see that it blows the breaker in someone's home, you want to put a meter right on here and make sure that when it's off, that that relay is open. How do you do that? I'll show you that one last thing here. That relay is this big black box here on the board. You just unplug the plug on that relay. You got two wires here. We go to ohms, and we touch those two terminals. What reading should I get right now? Here, I'm checking my meter, make sure it's working. I'm going to touch those two terminals on the meter. I got a reading, right? Meter didn't say nothing. That's good. Because when it's off, that relay should be open. When do I make that test?
When it's on.
I just said it. When do I check to see if that relay is stuck closed?
When the circuit breaker trips.
When the customer's using the microwave and they blow the breaker or blow the fuse inside the unit, before you just say, I need new door switches, you know, that they replace the door switches, the holder, and everything else. It looks like this. It looks like this. They replace this whole thing. Here's your 3 door switches. Your primary door switch here at the top, your monitor switch here in the middle, and your door sensing switch here on the bottom.
Are you supposed to drain the capacitor before you check that?
I'm sorry, what?
Are you supposed to drain the capacitor before you check that?
You should.
Even though it's technically charged right now, you won't get no reading?
Well, in order for that capacitor to shock me when I'm checking the door switch or the board, 2 things. One, that capacitor has to discharge through the transformer, and then the other side of the transformer has to discharge back into the machine before I get electrocuted. And when I unplug this wire here and I'm touching these 2 terminals, there's no wires connected to it. When I did that test here, I had unplugged both of these wires from the board. I had just 2 terminals. There's no voltage on those terminals. There's no way the capacitor would feed back to me with me disconnecting that whole plug. Okay, the shock I could get, but this is very well insulated, is actually if I touched one of these wires, it's possible the capacitor could go back through and electrocute and shock me that way. Okay, so door switches, monitor switch, you almost never check that unless it continues to blow the fuse or breaker every time you do it. Okay, primary and secondary or door sensing switches, those switches, each one has a different purpose. This one, if it's bad, you'll press start, the clock will never count down. This one is bad, the clock will come on, count down, just won't have no fans or turntable. That's it. So if I see this working, I know it's this door switch. If I see this working, I know it's that door switch. So this here is, to me, the better way to hold all that together. That design, if you look at this design here, you'll see it doesn't hold the door switches. I was able to, once I unplug it, I was able to pull the door switches out by hand. You see how easy I took out those door switches? This one here, you can see that little white dot right here? Let me see something. You see that white dot right there? Mm-hmm. That white dot is going through the door switch with a piece of plastic. That switch can't move. It's a lot harder to get the switch out because it has this plastic and this plastic and this plastic all holding it, but it don't move and don't blow the breaker. The new design on the other door switch blows the breaker. Any questions, guys?
So when you open it, and, like, say for instance the microwave on right now, and you open it, you could blow the fuse like that?
Yes, you could, if the door switches are not in alignment. This whole plastic assembly here has 2 screws here. And you can loosen those screws and you can move it up and down or whatever. So whenever you got a problem, a fuse is blowing.
Mm-hmm.
One, there are 2 hooks on this door. There's 2 hooks here on the door.
Mm-hmm.
One of them pushes on the switch this way, and the other 2 close the switch. Okay? So all 3 of those switches need to be activated at the same exact time. If that assembly moved, and you could take and loosen those screws, and you got a little bit of adjustment, you could go up and down with it. So when the hook goes in on the door, maybe it's not pushing all the way down on the button of the switch, so you move the switch up a little bit, make sure that they're all making contact. Anybody else got any questions?
I was gonna piggyback off of what he said. When I was in the field, there was instances where we would go. I forget which microwave it was, but they would call and say the microwave won't come back on, and it was because they kept opening the door before it actually stopped, while it was running, and then that switch would, or that was it a monitor switch or a switch or a fuse, something would blow every single time they opened it.
And that's probably because the switches moved in the bracket. Okay, I don't want to say the brand that's having this problem, but the switches move in the bracket. And a lot of guys order new switches, but they don't plug the wires onto the switches properly, so the switches can still move. But when one goes, they change all 3. You don't need to change all 3, but you definitely want to change the monitor and the primary door switch. There's the primary and the monitor. The door sensing, low voltage goes between that one and the board. You don't ever need to really replace it unless it's bad. But these 2 are powerful enough to blow the breaker or a fuse. So you always want to, if you replace one, you replace both. But you need to make sure that all of them are making contact at the same time. Okay? Yes, sir.
Every microwave don't have 1,000 watts, right? It depends on the size.
Yes, microwaves have different cooking wattages, yes. And it's usually listed on the model and serial number plate, the wattage of the microwave. Any other questions? Okay,